Hello everyone, my name is Lavinia Stiadu and today I'm going to present you Construct, a collaborative low-code platform for quantum application design and execution. Imagine you have no quantum computing experience, so you are a beginner and you want to solve a problem using a quantum computer. Take a simple example. You want to search for the element 2 in the list 312. Classically, you would check each element one by one until you find the right one. In the worst case, you might need to check all 3 items, and on average you check 1.5 items. With a quantum computer, you can use Grover's algorithm. But who will implement the algorithm for you? You could first try to figure it out by yourself by consulting textbooks, but this can take a lot of time. You could also ask a large language model, but can you fully trust its results? Lastly, you could ask quantum experts, but they often speak a different language, making knowledge transfer difficult if you cannot collaborate in a single tool. Therefore, you have to obtain quantum computing knowledge to implement the solution by yourself. For an expert, the process looks slightly different. The expert has to implement the same solution repeatedly for different users or problem instances, which can be time-consuming. To save time, it is helpful for the expert to reuse previously defined solutions by turning them into templates, allowing them to quickly apply proven models without re-implementing everything from scratch. Therefore, there exists a need for a collaborative quantum low-code platform, which I now present, called Construct. We start with the definition of our users. So we have one beginner and one expert. And the name of the beginner here is in this case Bob. And Bob joined the collaborative room, but he's currently alone in this room. And now he asked another user for help to solve his problem for searching the element 1 in a list of 8 elements. So we are now defining the expert. And the expert is now here defined, and he joins now the collaborative room. In this case, the name of the expert is Hugo. And Hugo now starts modeling Grover's search algorithm. So first he's dragging out the prepare state node, and he's selecting uniform superposition. And we're observing here that we have now users of different experience levels. So Hugo is an expert, so he sees the label prepare state in uniform position, while Bob, who is a beginner, sees input state and all options are equals. The labels are merged into a mixed view to allow the user to understand each other's vocabulary, but also to reduce ambiguity. So we have now our first state, the uniform superposition, which makes that all options are equally possible. So all 8 elements are now equally possible. And then the next element is to specify which element are we searching. And this is actually done by the oracle task. And the oracle means here to mark the element that I am searching. And the next element is actually responsible to increase the probability for measuring the correct element, so the element that I'm searching, but reduce the probability of the elements that are the wrong elements. So this is the job of the diffuser. And in order to extract the element that we are now have, we need to measure in the end. So we are now dragging out a measurement node and connecting it with the diffuser. And this is now our whole model. And we observe that the model is not complete. And this is where actually Bob comes into play, because Bob knows how many elements does he have in the list and which element he is searching. So we are switching now to Bob. And Bob is now specifying that he is searching the element 1. And he has in his list 8 elements, and we need 3 bits to encode 8 elements. So you specify this here. And now we are seeing that the model is complete. And when we switch to the other user, we see that the model here is also complete. So we can send now our model for transformation. So we are currently transforming our model into an executable quantum circuit. So in an executable OpenQASM circuit to allow the transformation on different quantum cloud providers. And now we are seeing that the transformation is successful. So we are now selecting the circuit for execution, and we are using QUANCOM to execute it on different quantum cloud providers. Currently, we are using now here a simulator in this use case. So now we are executing, and we are expecting now the element 1. And this is actually what we are seeing here. We had 8 elements, so the elements from 0 to 7. And the element that we are searching must have the highest probability, and this in this case the 1. And that's also the element that we specified earlier in our oracle. Thank you so much for your attention.